I can just ask you to pay attention to the board, can you tell me what must this represent? What must this be?
Acceleration.
What kind of graph?
Displacement.
It must be displacement time. Or it could be distance, but it must be displacement time. Why is that? Why can't it be a velocity time or an acceleration time?
Because we only deal with constant velocity. No, constant acceleration.
Yeah, we have constant acceleration. And for those of you doing methods maths, what would we call the shape of this? A parabola. And so we have what? Ax squared plus bx. C equals 0 or something like that, yeah? Now don't worry about this for those of you not doing methods maths, but it is a parabola. And for those of you who are doing methods maths, what we do know is that we can differentiate find velocity by differentiating. Okay, so that then would become 2ax plus plus x
Plus b.
Plus b, because you get rid of the
Oh,
x.
that's right. Yeah, thank you. I knew that. I just momentarily forgot it.
Without
just
b,
Don't
without
need
b,
the
don't
x.
need the x.
Oh, yeah, and I knew that too. Okay, and let's see how I do with this next step. Because we can then differentiate that to find acceleration. Which would be
2a.
2a.
Yeah, fun stuff.
Yay, got there in the end. All right, so that's for those of you doing methods maths, that this is the relationship between the three. And the other thing I guess that we need to look at is, well, what does that mean in terms of, for those of us not doing methods maths? Well, we can find the velocity at any time . Alright, so we're finding the tangent to the curve at any particular time. And this is the mathematical way of doing that, where you can just say you wanted to know the value for the velocity at time equals 3 seconds. Well, then you can differentiate and plug that in and find the velocity. That's easy peasy. We don't teach that though in Phys Sci, because you don't have to do methods maths to do Phys Sci. What we do is we say, well, in actual fact, what you're doing is finding the tangent to the curve. How do you find a tangent to a curve, and what is a tangent?
Straight lines that it's like the edge of the curve.
Yeah, I know that too. So I'm glad you do, because you're obviously doing methods maths. So to find the tangent, what we're looking for is we want to, if I start out with my ruler touching my curve at those 2 points there, I'm touching it at 2 points, right? But if I move my ruler such that I'm only touching 1 point on the curve at the instant that I'm interested in. So just say this then was the 3 seconds that I want to find the instantaneous velocity. Okay, so this will be instantaneous. So how fast is it going at 3 seconds is the tangent to the curve. You move your ruler starting out with it even on either side of the time that you're interested in, and then move the ruler back out away from that until it's only touching at one point. And then once you have that, you can then use rise over run to find the value. Okay, so remember that for a displacement time graph where it had a constant velocity, we were finding the gradient of that to find the velocity. This is the same. It's just that it's constantly changing. And so we use this to find the instantaneous velocity. And I could compare that with what the velocity was like over here. Let's just say this is at 1 second, where it's only touching my curve here at 1 second. What can you tell me about what's happening then to the velocity?
It's increasing.
It's increasing. How do I know the velocity is increasing?
The gradient is getting steeper.
The gradient's getting steeper for my tangent to my curve. We could also think that in actual fact the curve is just made up of a series of tangents. You could think of it that way too, where at each microsecond, if we're joining them all together, what we're left with is this curve that's representing that motion. Okay, and we just want to find at each instant what the velocity is. Okay, so whenever we see the curve like this, we know it must be displacement distance. It's not going to be velocity, and it's not going to be acceleration, because we only ever deal with constant acceleration. And for this reason, where we end up with constant acceleration, if this is displacement, we won't end up with constant acceleration if we're not dealing with a parabola like this. Does that make sense? So yeah, that's how we find the instantaneous velocity.